everyone. This is GATE 2022 Life Sciences Section B Biochemistry. Question number 33. The pK values of a carboxylic and amino groups of an amino acid with a non-ionizable side chain are 2.17 and 9.13 respectively. The isoelectric point rounded off to 2 places of decimals of this amino acid is dash. So this is the NPTEL online course reference in which they have explained the biochemistry of amino acids and the pH pKa of amino acids. So we have discussed this before also. Previously we have also discussed this. So this is a very nice table, and here we have different amino acids. So general structure of amino acid is very simple. All the amino acids are alpha amino acid, right? Why alpha? Because the amino group is attached to a alpha carbon. This is a alpha carbon. All amino acids are all the amino groups are attached to the alpha carbon. So all the amino acids which are found in the nature, at least in humans, are alpha amino acids, right? And this R group in the amino acid. So amino acids are classified based upon these R groups, okay? So we have R group attached to the alpha carbon also. So this R groups can either be polar uncharged R groups, then we have positively charged R groups, and we have negatively charged R groups, okay? So these are very simple. These are positively charged R groups, that is they have some NH4 plus group in the R group, right? Negatively charged R groups have a carbonyl R group which imparts a negative charge, and then we have uncharged R groups. So in case of serine and threonine we have OH. In cysteine we have SH, and then aspargine and glutamine also have polar uncharged R groups, okay? So I had mentioned this before also. There will be questions in biochemistry section in pH and pKa, and this chart has different pKa values. So I had mentioned earlier that we can assume the pKa values. We don't need to remember all the pKa values of all these amino acids, right? And how can we assume this? So as you can see, we have pKa values here of a carboxyl group, okay? So in amino acid we have a carboxyl group, amino group, and R group. So we have pKa of carboxyl, amino, and R group, okay? So as you can see in this table, the pKa of a carboxyl group, we can approximate this pKa of carboxyl group to as 2, okay? We can approximately consider the pKa of carboxyl to be 2. Similarly, the pKa of amino group, amino side chain, right? As you can see, this is pKa of amino side chain. This could be approximately taken as 9, okay? And this is very easy to remember. The pKa of carboxyl of a carboxyl side chain can be taken as 2, whereas the pKa of a amino group, amino side chain, can be taken as 9, right? This is very simple for us to remember. Now the only difficult part is to remember the side chains or the pKa of the R group side chain, right? So cysteine, we have to remember it is 8.8, slightly towards the positively charged R group pKa value towards 8. So the amino group side chain we have 9 and the cysteine has 8. Okay. Similarly, the positively charged R groups, they'll have intuitively we know that all the positively charged pKa values will be similar to that of amino side chain pKa values, right? So they have approximately 10 and 12, right? Approximately we can consider that lysine and arginine side chain to be approximately equal to 11, a slightly higher than that of the amino side chain of the amino acid. Okay, and histidine, it is very easy to remember histidine. So histidine, I have mentioned this earlier also, that histidine pH, histidine pK, histidine is a very important amino acid. It has pK around 6, right? It has this pK around 6. Why? This histidine amino acid is mainly involved in lot of enzymes. Okay, and when this histidine is in a protein, this pKa from 6 goes to 7, and this 7 pKa is very important. Why? Because this is matching to our biological pH, right? Inside cell we have pH around 7.3 or so. So it is exactly matching, not exactly, it is approximately matching to our biological pH. Okay, so you can remember histidine. Histidine is very important amino acid. It has pH approximately around, a pKa of the side chain is approximately equal to 7. Okay. Then we have negatively charged amino acid, and those pKa values will match to that of our carboxyl side chain. Okay, so our approximate carboxyl pKa value is 2, and for the R groups, negatively charged R groups in aspartate and glutamate, the pKa we can approximately consider to be as 4. Okay, these are the few tricks and very important, you have to remember this, right? So next is we need to calculate isoelectric point. So this is also very simple. What is an isoelectric point? It is a pH, right? It is a pH value. It is a pH value at which the overall charge on the amino acid is 0. So the overall charge on the amino acid is 0, right? So in order to calculate isoelectric points of different amino acid, we have 3 different sections of amino acid, right, with us. So we have a positively charged amino acid. Okay, and to calculate positively charged amino acid, we have a different strategy. For negatively charged amino acids, we have a different strategy to calculate isoelectric point. And finally, we have a uncharged amino acid, right? Uncharged amino acid. And we have a different strategy for the calculation of isoelectric point. So let's first start with the positively charged amino acid. So one of the example of the positively charged amino acid is lysine, right? Very simple. First we'll write the backbone structure of lysine. This is the alpha carbon to which we have a amino side chain, and this is our R group. So the R group is CH2 4 times NH2. Okay. So in the positively charged amino acid, there are 3 ionizable groups, right? We have amino group, which is ionizable. It can be protonated, right? We have carboxyl group. which is ionizable, it can donate the proton and it will become negatively charged. And we have again one more amino acid, right? And this amino acid can also be protonated, right, depending upon the pH. We already know, depending upon the pH scale, it could be either protonated or deprotonated, right? So the formula for isoelectric point is, donated as Pi. So there are so we have to take a average charge, and to calculate the isoelectric point we first have to know the pK of this amino acid and pK of the R group. Okay, positively charged R group. So we all know the pK of amino group is approximately 9, right? Whereas the pK of the side chain amino group is 11, right? That's what we assumed. And upon, we have to take the average charge. So this will be 20 by 2. So the isoelectric point is approximately pH 10. At pH 10, so what does this mean? That at pH 10, what will happen? There will be a zero charge, right? At pH 10, there will be a zero charge on the lysine. So it can be a zero charge when we have either this protonated group, we have either this R side chain protonated, and the carbonyl can be deprotonated if this proton is abstracted. So the overall charge is 0, right? The overall charge of this amino acid is now 0. Okay, so at pH 10, either this amino group can be protonated or this amino group can be protonated, and then this have to be deprotonated to give a negative charge, so that the overall charge is balanced and the overall charge is 0. So at pH 10, lysine will have a 0 overall charge. Okay. Similarly, a negatively charged amino acid is glutamate, for example. So in glutamate we also we have a negatively charged R group, right? This is glutamate, right? Very simple. Everyone please practice all the amino acid structures. It is very important. So similarly, we know that we need to know the pK of the negatively charged groups in a negatively charged amino acid. So in the positively charged amino acid, we need to know the positively charged side chain pK values. In negatively charged amino acid, we should consider negatively charged side chain groups pK values. So again, we already know the carboxyl pK value is approximately 2, right? So the Pi is the average charge. So this pK value is approximately 2 and this pK value is approximately 4, right? So this will be 6 by 2, 3. So what does this mean? At pH 3, what will happen? The glutamate will have overall charge to be 0, right? And this could either be if this carboxyl group is deprotonated and we have a protonated amino group here. We have a protonated amino group here and this carboxyl group is deprotonated. So at pH 3, what will happen? This carboxyl group will lose its proton. It will become deprotonated and have a negative charge, whereas the amino group will be protonated and it will have a positive charge, right? And what will happen in case of uncharged amino acid? So let's take any uncharged amino acid. It could be any it could be either side chain is uncharged or any non-polar amino acid. So let's take a simple example, glycine, very simple. Right, glycine, the side chain, it doesn't have any side chain, the side chain is hydrogen, right? Glycine is the only amino acid which doesn't have any side chain, it doesn't have any R group. The R group is hydrogen itself, right? Very simple amino acid. So since it has only amino group and carboxyl group, what we'll do, we'll take the pKa values of amino group and carboxyl group. We already know the pKa value of amino group, which is approximately 9, and the carboxyl group is 2, right? So this will be 11 by 2. So approximately we'll have 5.5. So at pH 5.5, the overall charge of the glycine is 0. Right, the overall charge on the glycine will be 0. Okay, very simple. So in case of positively charged amino acid, we should consider the amino side chain and the amino positively charged amino side chain of the R group. Okay, so the amino group of the amino acid and the amino group of the R side chain. Whereas in the negatively charged amino acid, we have to consider the carboxyl group of the amino acid and the carboxyl group of the R side chain. Okay, very simple. So coming back to the question. Okay, so they have given us in the question they have mentioned the that the side chain is non-ionizable, right? So we are left with only the NH2. So we don't know what is this amino acid, so we are left with the NH2 pK value and carboxyl pK value, and they have given us that the amino group pK value is 2.17 and the carboxyl and group pK value is 9.13. So the PI will be very simple, 2.17 plus 9.13 upon 2, the average charge, the average pK, right, will tell us the isoelectric point. So what we have here, 11.3 upon 2, which is equal to 5.65. Okay, 5.65. So the correct answer is 5.65. So when I told you to assume the pK of amino to be 2, approximately 2, and the pK of carboxyl to be approximately 9. Okay, sometimes what will happen in the question, they won't mention this pK values, right? Sometimes they will not mention this pK value, so you have to assume that it is 2 or 9. Even if you assume it is 2 or 9, the answer will be somewhere around, right, what we calculated previously, right? The answer will be somewhere around that, and it will help us to solve the question, right? So that is why it is very important that you remember this pK values of at least few amino acid. Okay, so here the answer is 5.65. Thank you.